Greetings, fellow rackheads. Dirk here, and I'm here to talk about hacking rack. Today in the lab, it's the last video on the care and feeding of your catalog. In the last video, we talked about using a fork that I've created, a VCV rack, with a new feature in the file menu called catalog that will generate a complete catalog for all the plugins and associated modules that you've got installed. That does require you running a fork or a compiled version of that. I have another option for those of you that wish to run standard rack, and that is based on a plugin module that I've created. So I want to walk through that today. So as usual, I'm going to fire up my lab in IPython Notebook. Going to go to the VCV project directory, and I'm going to start up my notebook. You can pick up my catalog management plugin from my GitHub page. It's in a project called DLwigglz, because I like to wiggle in both my Euro rack and VCV rack. So you can just clone that project or pull a release if you'd prefer to do that. I've got releases available to you. And as you scroll down, I give you a little bit of background on the plugin. But I wanted to talk about and demonstrate using that and supplementing the catalog. So first I'm going to go back and fire up my VCV rack. And this is just any version of VCV rack, either my fork or the standard 060 release. And I'm starting with a blank project. I have a project called blank, which isn't my template, by the way. My template starts with a clock source and an audio output. So I'm starting specifically from scratch here. So if you, just the normal way, once you install my plugin, you just drop it into your plugins folder after downloading or building the binary. If you pull down the release, you just drop it in your plugins folder. It will unzip itself. You'll find my stuff under DLwigglz. And I've got an initial plugin called Rack Hacks. So let's add that to our project. And you'll see there are two main elements to the interface. I can either create a partial catalog, or I can generate full documentation on the current patch. So let's demonstrate both of those. So I'm going to click the patch button. It lights up a bit, and voila, you have just saved an entire subcatalog of the patch. So let's take a look at that. And I literally save it in a file called patch to not override the existing patch that you're working on. And let's pipe this through our old friend JQ to make it look a little bit nicer. And this is literally the patch. Notice that in the section where I talk about the particular module, Rack Hacks, you'll see that there's a width value in there. See how it captures the width? Normally when you save a patch out of VCV rack, it does not save width. And sometimes we like width. Remember the first video I did generating the documentation patches? In order to lay those out, I needed the widths of the various patches because I was generating those patches in advance automatically and just loading them up. So that's kind of cool. Second feature is I can generate a partial catalog. Now, because this is running as a plug-in module and not part of the core VCV rack process, it can only generate a partial catalog. The missing piece of information is width data. So when I press the catalog partial button, it generates a partial catalog for me, and we can go look at that as well. And of course, I'm going to push that through jQuery. And this looks identical to the normal catalog that we generate through the fork, with one exception. Notice that when I go into this last plugin, you'll see that it has one module, and it lists all the normal information, but it's missing the width data. Now, you may or may not need width information in your catalog. So this would give you a great piece of metadata to generate documentation, written document or printed documentation, but it does not have the width field that you could use to lay out patches, do things like that. Anything dealing with layout requires width. So now that we've got these files, let's go to the lab and see what we could do with this stuff. So I'm going back to my rack CLI folder, and I have a rack cloud project. And again, just as a reminder, I really enjoy using Jupyter notebooks because they give me the ability to combine documentation and runnable code in one file, in one place that I can look at it. And if you've ever written any code, it's not always fun to come back 6 months, a year later, and just see source code. Even with liberal use of comments, it's not the same as having something like this where I can tell whole stories interspersed with my code. So as I demonstrated in the last talk, you can run a code fragment by hitting Control Return on a Mac. So I'll go ahead and just run a few of these items. What I'm going to do here is I'm going to open up a couple of items. I'm going to open up my real catalog that I created in the prior talk using my fork. And remember, it includes width data as well, and this partial catalog that I just created for you. And I'm also going to open up my docs patch. So let's go ahead and run that code. Here's an example of interacting with the Amazon Cloud Service S3, which is a place to store files. It's kind of like a file system in the cloud. And you're probably thinking, well, I thought we were talking about VCV Rack. Why is he talking about this? Well, this round of solutions that I'm going to talk you through today are comprised with what I've demonstrated, generating catalog kinds of information, either with or without width data, on your local machine via a plugin module. And the second part is, well, if I create documentation on a patch, I get the width for the items in the patch, but that doesn't give me the width data for the rest of my catalog. So to help solve that problem, I've created a cloud-based service. It's a crowdsourcing kind of service where if you want to, and you have a full catalog, you can share that detail to the cloud, to my service, and other people can, based on the modules that they have, go look up that additional data and incorporate it into their catalog. So I'm using Amazon as a place to implement some of that stuff. And one of the things I've chosen to use is S3 to store some of that extra information. So here's an example of how you could read and write files from S3. Now, I'm not going to play with that much now because that was for my benefit because this is the lab. But what I wanted to show you was this section. So imagine you have the partial catalog, and imagine that the rest of the data, width, etc., is up in the cloud, but the cloud definition is what I like to think of as the universal corpus. It's got documentation on all of the modules, all of the plugins, and many of those I don't even have installed on my machine. So what I want to start with is I want to look at my machine, get just a basic list of all the plugins that I have, and submit my plugin list to the cloud, and have the cloud give me back the missing pieces. Now, it's possible that I might have something newer than what's reflected in the cloud, and those will come back earmarked as unknowns. Because I'm uploading either, the service supports two things. I can either share my complete catalog, again, that came from my fork, or I can sync up my catalog partial with the catalog in the cloud. So you're going to see two kinds of services, share and sync. Share is where we're giving our detail to the cloud so it can be shared with other people. Now, if I'm going to share some stuff, I need to make sure it's correct. So I've got functionality to verify that the transaction or the formats of these requests are correct. I've got functionality that will look at my catalog and come up with that specification. So that's what I wanted to show you now. I'll go ahead and just run this block of code. And you'll see, here's that example of what an entry looks like. And it's got a piece of width data, and that is at a module level. Now I can go ahead and use what was calculated up above to actually do the share request. So what I've got here is a cloud share function, and it takes a request and processes against the corpus. Now, this function would actually be running in the cloud. Okay, so the request, again, it looks at my catalog and creates just enough data to provide the width, to contextualize each width. And it would be a list of those, because I have, in my particular example, I've got about just a hair under 100 plugins, each with potentially lots of modules. So you can imagine this being a pretty big request, and so I want that to be as lean as possible. So let's go ahead and execute this. Now, if there's already stuff known by the cloud, it'll just ignore those requests. So it primarily just processes new incoming data, new width data for plugin modules. Also, there's error checking in there, so if you send it the wrong kind of information, it will let you know that it was incorrect, it was invalid, and it won't compromise the cloud database. So that's the share. Again, share is for situations where I have a complete catalog and I want to share it with the rest of the world. Now, the flip side of that is sync. In our example earlier, we used the module r4xH4xDLwigglz to create a partial corpus, a partial catalog, and we want to augment that with width data. We can do that with this series of services. So the difference on the request here is all I have to do is tell it what plugins I have. And in this example, I have a request with #1 and #2. Those theoretically might represent two plugins that I have installed on my machine. Okay. The next series of functions help you create that request, and then there's an example of submitting that request. So I'll go ahead and run that. Now, in this particular case, I did something kind of weird. I looked at my example catalog and I came up with all the real plugins I had, and then I came up with a goofy one, a made-up one that I knew was just not good. So, and I named it #dude 16 times. So that's the right length, but it's not real. So when I go to look that up in the cloud, it's going to go look up dude all day long. And of course that doesn't exist in the cloud database. So it's going to come back flagged as an unknown. So in my output here, I reference what's been submitted and I get back some unknowns. And you'll see there's that dude that got identified as unknown. Now, everything else worked great. So in my particular case, in this example, I literally submitted just under 100 plugin hashes for all my plugins that I've got installed. And those all got merged in if they were new or ignored if they were old. And out of that whole batch, I only got one that was unknown, and it was the one I made up. So it caught that as well. Now, if you do this partial resolution with the sync, you now have a valid data file that you could merge in. So here's an example of a function that you could use to integrate what came back from the cloud to supplement your widths. You could use this to merge that into your existing catalog. And I've got an example where I invoke this function, and up above I created a file called partial, which is my partial catalog, and I'm going to sync it up with the cloud, and what I get back is something that I can pass to this fixer, and it will merge those two together. And just for grins, I went ahead and wrote that out. This is the way you can, remember, all VCV rack stuff is stored in JSON files, so this is the way you can take a data structure that you have in your your scripting environment. In my case, this is Python code. So I have a Python data structure that represents the catalog. And I'm going to go ahead and write that out as a file called catalog.fixed.json. So now on my computer, I have three files. I have a catalog.json, which is the real one that I got from my fork. It includes with data. I have partial catalog, which was generated from my plugin, r4xH4xDLwigglz. And it is only partial. It does not include with data. And then I have this now third file, which is applying the fixer to my partial after calling the cloud service. It says, hey, can you give me the rest of those widths? And I write that out in a file called catalog fixed. So now what I'm going to do is, if you're used to like shell scripting and stuff, you'll be familiar with a cool command called diff, D-I-F-F, and that'll compare two files and show you the differences. So first thing I want to do is I want to see what the difference is between my catalog and my catalog partial. Okay, and this is going to return me some sort of ugly looking text, but anytime there's a difference, it'll tell you what it used to be and what it is now. If there's no difference, you'll get nothing back, and that'd be what we'd want in a perfect world. So let's compare these two. And you'll see, I get a whole bunch of data back, but in essence, it's all saying that one of the files has with data and one doesn't. That's what this sync set of services resolves for you. So now let's compare catalog to not catalog partial, but catalog fixed, and see what we get back. Ooh, perfect. So that says there is literally no difference between my catalog and the catalog that I generated with the fork of VCVRack and the partial catalog plus the sync cloud service. So that means I'm golden. I've got a complete catalog. Now, the only dependency is, again, that the definition, what I call the corpus in the cloud, is complete. Now, the good news is I use this software, so I'm going to be, every time I get new plugins, I'm going to fire this thing up and submit my additions, so the corpus will get bigger. And in a perfect world, as developers implement new modules, if they would get in and do this same thing, then before we even saw those modules in the plugin manager in VCVRack, that cloud data would already be there. So if the developers, when they get ready to release plugins, would run these kinds of tools, then that data would be up there. Now, what I've demonstrated is in the lab. Now remember, I have a project called r4xCLI, and that's where production versions of things that I do in the lab might end up if you guys think they're important. Now for me, when I'm doing hardcore stuff in VCVRack, I've got my Jupyter notebook running because I'm hacking all over the place. You know, 3/4 of the stuff I'm doing, native VCVRack. But 25% or so, hey, I'm hacking. I'm hacking and cracking. So I'll have both of those open. That's not necessarily the case for everybody. So that gives you two avenues. You can generate full catalogs from the fork. You can generate partial catalogs through the plugin module, plus supplement that with data through sync and share services. And those are, as I'd mentioned before, in this Rack Cloud project. Now, this literally is in production already. So if you go up to Amazon Cloud, you can actually run these now. You can sync and share. Just remember that if you're syncing, what's expected is a list of your hashes, and there's a function here that will create that for you. That's what Cloud Sync Partial Request does for you. It generates that specially formatted request. What I can do is I can take this sync code and this share code and wrap it into VCVRack. So it'll just be super simple. In r4xCLI, that would be really straightforward and foolproof. So for example, it might be something like r4xCLI space sync, and you're done. Or a r4xCLI space share, and you're done. There might be optional arguments to specify particular files that you might want to sync or share, but it would be really straightforward. You wouldn't have to install any other tools other than r4xCLi, and it would be super straightforward. Again, just let me know if you want me to migrate any of the features from the lab to r4xCLi. That's the last in what I consider the plumbing talks. So we've seen how to document our modules. We've seen how to generate and maintain a catalog 2 different ways, one with a rack fork and one with just a plain module, plug-in module, with the support of a web service. But that web service is already in place. In future talks, we're going to tend to focus on more real-world problems that take advantage of some of this infrastructure, but this kind of completes the infrastructure talks. And that's a wrap for today. Thanks for stopping by. Don't forget to like and subscribe, and see you for the next video.